Okay, you can see the dynamic.
We still have a lot of people entering the.
Yeah. Give a couple of minutes. I guess it's because it's empty a lot of people.
We are almost 50 attendees already on board.
Okay. I think now, okay. Again, welcome. We are recording the workshop. We wait, you don't have any inconvenience to this. The workshop is split in 4 parts. Let's show you the agenda. Do we have some? Let's see what happened. Now, one more. Now. Now, you can see the agenda, no? It's okay? Perfect. The workshop is split into 4 parts. First, we will see a brief introduction of the project. After this, one session in which we will see AI-powered risk assessment based on real-world data gathered for users. On session 2, we will explain about big data analytics for risk assessment. And to finalize with an open discussion. We are going to use a Slido during the event in order to get feedback from you. Also, you can post your questions in a Slido or also using the chat. But let's start with the first presentation from the workshop. Is Vittorio Monferrino from GFT Technologies, and he's going to give us an overview of the INFINITECH project. Vittorio, welcome. The floor is yours.
Hi, thank you, Carmen, for the introduction. Good morning to everyone and welcome to this workshop. Let me share my screen. Okay, so my name is Vittorio Monferrino and I am Deputy Project Manager of the INFINITECH project. INFINITECH is a flagship project in digital finance, and it is one of a kind. And why is that? Because the financial sector is historically conservative and therefore resistant to digital transformation. And despite the rising investments in big data, IoT, blockchain, and artificial intelligence, the financial institutions are still facing many challenges in implementing those technologies. And there are several reasons for this. For example, the financial new solutions. Usually, financial institutions have very complex systems that are not easy to be changed. And last but not least, all the financial institutions are regulated by vast amount of regulations, of compliance systems that are set very high. You hear a lot of background noise. And this vast amount of regulations set very high barriers in order for the financial institutions to proceed with innovation at the right pace. So before explaining how INFINITECH aims to tackle these problems, I give you some numbers just to give you an overview of the dimension of the project. So INFINITECH is a co-funded project by the European Commission in the Age 2020 framework. It is an innovation action, and its budget is more than 21 million euro. In the project, there are more than 50 partners, and it will last for 39 months. We are now in the middle of the project. And one important innovative side of INFINITECH is that it leverages on testbeds and sandboxes in order to safely deploy the pilots. Today, you will see in the workshop some of the pilots that are part of the INFINITECH project. And the main focus of the pilots that you will see today is related with insurance and InsurTech. So INFINITECH aims exactly to tackle the problems that I just mentioned. How? First of all, by lowering the barriers for big data, IoT, and AI-driven innovation, then boosting regulatory compliance and stimulating additional investments. How to do that? INFINITECH is based on 3 different pillars. You see here innovation, execution, and market. INFINITECH is defined as innovative because it leverages on novel technologies and because of its reference architecture. Its reference architecture is flexible, interoperable, and follows the pipeline approach. My colleague Jose, after me, will explain you a bit more in detail how the INFINITECH reference architecture works and is structured. Then the second very important pillar is execution, because INFINITECH has a pool of 15 different pilots, and all those pilots are developed and deployed, as I said before, in testbeds and sandboxes. The third pillar is market, because INFINITECH is both market and industry driven, and all the pilots and use cases follows the market. And because of its marketplace that is available online, and its VDIH, so the Virtualized Digital Innovation Hub, that is specific on the financial sector. So as I was saying before, INFINITECH has a consortium of more than 50 partners, and you see here the distribution of the sectors of those partners. They are all spread in all over Europe, and we have innovation represented mainly by researchers and universities. The execution by, let's say, the big players on the market, so the integrators and the digital finance vendors. And then the market, on one hand, from fintech, insurtech, and other small, medium enterprises that are highly innovative. On the other hand, from big financial institutions, such as banks, insurances, or payments providers. So in a nutshell, INFINITECH aims to exploit its pool of global leaders in ICT and finance in order to develop innovative solutions. All the pilots that are contained in INFINITECH are related with big data. So the data sets that the different pilots rely on are all very big, and all the applications are data intensive. And indeed, the innovation of INFINITECH aims exactly to exploit those vast amount of data in order to develop fast and effective solutions. Also related to the vast amount of regulations that are present in the financial sector, INFINITECH will build and is building regulatory tools, trying to tackle and address all the different regulations that are present in the financial sector, starting from anti-money laundering to PSD2 to GDPR. Last but not least, all the technologies developed in INFINITECH are innovative, and most of them relies on high-level analytics. So artificial intelligence, machine learning, deep learning, high-performance computing, and so on and so forth. The pilots of INFINITECH, as I was saying before, are 15, and they are ranging from all the sectors that are present in finance. So banking, payments, capital markets, investment, insurance. They go from investment banking to anti-money laundering, to insurance in the agricultural sector, to insurance in the health sector. And as I said before, the workshop of today is specifically focused on 4 pilots that are in the insurance sector. Apart from their sectors, they also covers all the range of applications. So from the front office to middle to the back office. Implementing several functionalities and features in order to tackle real problems with innovative solutions. So starting from, let's say, the more known chatbots to know your customer, to, for example, applying blockchain and smart contracts in novel and innovative applications. So to conclude and give you also an overview of where we are now in INFINITECH, we are now in the middle of the project. Here you see a kind of roadmap of the pilot's development in the project. We are now near to month 18, and that's why we are doing this workshop today, because the pilots in the project now are developing demonstrators, MVP, POCs, and we have some results to show. And today, all my colleagues and all these sections are intended to show you how the pilots in INFINITECH are done and how they address real problems with innovative solutions and innovative ways. And I'm done. I thank you for the attention, and I think I would give the floor to Jose, who will explain you a bit more in detail the technical side of the INFINITECH project. Thank you.
Thank you, Vittorio. Yes, now Jose will start. Jose, the floor is yours.
Yeah, so hello everyone. Thank you, Vittorio. So let me continue the event. I will share my screen. Okay, so I guess that you see my presentation. My name is Jose Gato. I work in Atos, and in the project INFINITECH, I am the let's say the main leader about the implementation of the different pilots of the project. So after Vittorio presentation, I will give you just a very quick presentation about how we organize all these 15 pilots. Okay. So as Vittorio said, INFINITECH is a project where we will have 15 pilots related to financial and insurance companies and how they can bring new innovative technologies like IoT, big data, blockchain, artificial intelligence, etc. And we will do it through the demonstration of 15 pilots, and we will create different test beds and sandboxes from this pilot. So how do we organize everything? Because as you can imagine, so these 15 pilots are not working in the project, let's say, in an isolated way. It's not like they are working on their own with the requirements, developing and preparing the pilot. So what we are trying to do is to detect common things that they will have in common. So this is why we group the different pilots in clusters, and each cluster is composed by pilots that will share a common objective, maybe a similar business need, similar requirements. Maybe they will solve their problems in a similar way with similar technology, or even with the same technology that they will share between them. So this is why we propose it to have 5 clusters with different objectives each one. So for today, this event is focused on 2 of these 5 clusters that are the cluster more related to insurance companies, and the topics are personalized use-based insurance pilot and configurable and personalized insurance products. Later we will see the presentation of these pilots in this cluster that they will talk you about the things that they have in mind. Again, pilots will not work on their own way. They have to do it, we will propose the INFINITECH way, where, for example, we have a common reference architecture with common layers and, let's say, common, in some cases, common components, building blocks, software blocks, services that can be combined and, depending on the needs, can be shared between different pilots. In principle, in the same cluster, but of course, some of these blocks, of course, will be shared and combined between pilots of different clusters. Then we have this reference and architecture. And with having this reference architecture, the requirement, the services will build the test beds and sandbox. A test bed is, let's say, that is the infrastructure, the hardware, where we deploy the reference architecture. Okay, the different components, the different services, etc., will be deployed in an infrastructure in order to provide what we call is the sandbox. That is the, let's say, the services, the APIs, the applications, that will work as demonstration and will implement the business needs of each pilot. We have different options. Some of these testbeds are on premises, others are on cloud. Some of these are more open. Some of these are more closed. But the idea is that each pilot will have a secure playground where they can use data, implement services, and do the different demonstrations that they need to do with these new technologies. So, okay, very good overview. And the cluster is a common place where the pilots will share technologies experience. We have the reference architecture that guide these pilots about the INFINITECH way of doing this or implementing the use cases. And finally, this idea of having test beds and sandboxes as playgrounds to do the demonstration. Some of these will be even open and can be replicable for other stakeholders, even outside the project. For today, we will focus in the cluster of insurance companies. Now we will see the details. Our idea for this event is not only showing the things that we are doing, the things that we have in mind. We want also to have feedback, to know your opinion, to maybe understand what are your needs. Most of the people invited today belong to companies with some kind of relation to the topic of this event. So maybe we can learn from each other, we can share experience, have some feedback, and of course continue with the project. To do this more interactive, we have created a set of different questionnaires that will be shared after each pilot presentation. Starting, I think, from my presentation, you have a very quick questionnaire that we please ask you to fill it. In order to have this collaboration, okay, to do it more dynamically, not only ourselves talking about the project, we want to do it as more interactive as we can. So let me check. I guess that you have already the link to the questionnaire.
Yes, Jose, with your permission, I would introduce this part.
Okay.
So, yeah, good morning to all of you. My name is Dimitri Pap from Atos, and I will be a questionnaire moderator of this session. To navigate and user-friendly. So you will have two ways to access to Slido tool. If someone has the mobile app, so you just have to introduce the code, or if not, so I will share with you right now the direct link to the access to this platform and answer to the questions. So the link is there. Just click the link, and the first question is, let's say it's our pilot question. So just use this link and answer to the first question, which will we will give you more questions for have your feedback. So usually we will have around 30 seconds to answer, but for this first question you have a lot of time just for a check if everything is fine and you can access. If you have any questions, so please put your questions here in the chat. Okay, yeah, Jose, you can continue with your part.
Well, okay, I just finished it, yes. So yes. Thank you everyone.
Thank you for all of you. Let's move to the following point in the workshop, the session 1. User. Now we have two interesting presentations. Andreas Politis from Dynamics is going to chair this session. Also, he will be with the colleagues Ignacio Licegui from Atos and Aristo Demos from iSprint. Please, Andreas, the floor is yours.
Good morning, everybody. Let me share the screen. Yes, now you see my screen, right?
Right.
Okay. Okay, thank you, everybody. I would like to welcome you as well in our first insurance workshop. My company, Dynamis, is a PNC, Property and Casualty Insurance Company, and is the business partner providing insurance expertise in Pilot 11 and Pilot 12 of the INFINITECH project. Let's start with Pilot 11, personalized insurance product based on Internet of Things, IoT connected vehicles. What is the problem we face in motor insurance, or better in every insurance sector? Accurate risk assessment. Of course, nobody says that the science or statistics or the actuaries don't do a great job. But what's the traditional way? How insurance companies are estimating risk and calculating premiums? It depends, of course, on the driver, age, experience, or even gender. On the vehicle, age, value, brand, model, or even color. And finally, on the location or user place of circulation, if it is in a city or in the countryside. Well, the problem with this approach is that premiums are not affected by the actual usage and only change after a claim. The solution to this problem is the usage-based insurance products. So far, we have the pay-as-you-drive insurance products, meaning the more you drive your car, the more you pay, and we have this information from odometers, GPS devices, or mobile apps. We have the pay-how-you-drive service, with the addition to the mile coverage information about braking and accelerating. Of course, these two products already exist in the insurance market, although not fully integrated, but there is room for improvement there. In INFINITECH, we call it the pay-as-you-drive service, but it is actually a pay-how-you-drive service with higher level of accuracy. We have the connected cars using onboard units, weather data coming from weather stations, and reports of traffic incidences like accidents or roadworks. So we collect numerous data models from 3 different sources, as I said, processing them to reach the desired result. But what exactly we collect? Now we'll ask Ignacio from Atos, our pilots leader and technology provider, to give you more details. Ignacio?
Okay, thank you, Andreas. Can we see the whole slide, please?
Sure.
Yes, because within the Pilot 11, we are collecting mainly 2 different data sets. The first one, the data coming from the connected vehicles, and data what we call context data, which is gathered from different data sources external to the car, but directly related to the way the cars are driven. Well, starting with the first set, with connected cars, mostly current vehicles are composed by a wide set of sensors and devices, continuously capturing data from the vehicle status and the different driving parameters. This set of sensors are connected through what we call the standard CAN bus to the central onboard computer of the car that somehow aggregates all this information to show this in the vehicle's driving panel. This is what we usually see as the speed and so on and so forth in our car. Well, within Pilot 11, we have a specific component installed in the vehicles that enables the gathering and uploading of all of this information in real time, captured in real time from the vehicles to the pilot's framework. So we can process and analyze the speed, the acceleration, the location, the hidden of each vehicle, and also the status of the wipers, the blinkers, the lights, and so on. Okay, we have fresh data from the connected cars. On the other side, we also enhance this driving analysis by adding from official sources extra information like weather information, traffic alerts and incidents, and road-specific information such as, for example, the maximum speed allowed in a specific road segment. Everything and always collected around the area the testing vehicles will be driven. Okay, that is would be the set of data we are collecting within and managing within the pilot. You can continue, Andreas. Thank you.
Okay, thank you, Ignacio. Having all this data and using artificial intelligence techniques and machine learning algorithms, we create in our pilot 5 different driving profiles. Starting from considered drivers and identifying the driving behaviors, different level of aggressiveness. We have aggressive, but very aggressive, or extremely aggressive driver. We will see how later on. This way, insurance companies will provide personalized insurance products based on connected vehicles, and the result of this classification will be reflected in the premiums. As we see in the flowchart, it will be reflected in frequent intervals, could be a month, a week, or even a day. And of course, the rest of the triggering factors for a premiums change, like an accident, remain the same. Let's see some of the numerous scenarios that we use to generate the driving profiles and to classify drivers in these profiles. We start from simple ones, driving above speed limits or turning without using blinks. And we'll go on to more complex scenarios. Here we have a frequent change of lane in a straight road, not reducing speed in severe weather conditions like heavy rain or storm, and driving with no lights at night or in foggy conditions, and driving without reducing speed when approaching area with car accident or roadworks. As you understand, these are very few scenarios compared to those we can use to classify drivers. There are much more combinations with all this data, but it's pointless to mention all this in our presentation today. Another problem in motor insurance to deal with is fraud detection. The means insurance companies have to detect the fraud in a car accident so far are, let's say, police reports, eyewitnesses, cameras, and the court procedure. Experts or even investigators who find inconsistencies between the actual damage of the involved vehicle and the reported claim. And of course, posts from social media that may reveal hidden facts about the accident itself or a relationship between the drivers involved. What if we could use our data capture to find out that the actual circumstances of the accident or the place of the accident or even the driver are different than those reported? Here are some use cases that we can detect fraud with the process of the data mentioned. The vehicle reported to be involved in an accident is different than the real one. It happens. Or the driver reported is different than the real one, or different than the usual driver of the car. This may happen because the actual driver has no driving license or wasn't supposed to drive the car. And another very common use case, to report an accident at a different location. Of course, it can be reported in a different country, but you get the point. You may say that some of them can be detected with a simple GPS tracker, and you are right, but not this one. Although I admit it's a long shot, what if we could detect speed and driving reaction before the moment of the accident? And generally the circumstance of the accident. We could also detect the driving behavior in a time period before the accident. That will give us info of the mental state or the mood of the insured driver the day of the accident. And last but not least, we could detect some fake car thefts. What are the business innovations here? What business innovation INFINITECH brings to the insurance business? In the pay-as-you-drive service, as we said, we have the use of onboard units providing us real data from vehicles, not from a mobile app where you can import inaccurate data by yourself. And we have real-time traffic information about accident and roadworks and real-time weather conditions. Both of them, I believe it is the first time to be considered in usage-based insurance products. What we get from all that? personalized motor insurance product based on the actual usage, so based on the actual risk. And one more innovation is the fraud detection service, as we said. With all this data collected and processed, insurance companies have the tools to identify most of the fraudulent acts against them. Now I will give the floor back to Ignacio to present you briefly the pilot architecture and the technologies used to implement the services. Ignacio?
Yes, thank you. Thank you, Andreas. Well, in terms of the pilot's architecture and trying to make a simple view of our workflow, we have within Pilot 11 the real time data sources composed by 20 connected vehicles, plus the weather, traffic colors and roads information sources. Yes, we also have a tool to manage simulated scenarios with synthetic traffic. Simulated scenarios with synthetic traffic and connected vehicles that helps on the data capturing processes, data formatting, and AI models development, training, and so on and so forth. All this data is captured, homogenized, and stored by the Smart Fleet component that in turn serves all this structured information to the pilot's artificial intelligence platform, that this aggregates and exploits all this information to explore different machine learning, deep learning technologies that define and train the corresponding driving profiling and driving classifications AI models, what we are developing within the pilot, which finally supports and later caters the fraud detection and the pay-as-you-drive service. This will be the main components of the architecture. Okay, then these two services we have created will be later offered to the insurance companies as let's say as a standalone application. This is the insurance company will call this provided, these developed services using their own data captured from their insured clients, and so get the corresponding outcomes. This means that all data flows are generated and consumed within the insurance company, and no info is shared outside its network. So this way, GDPR is somehow warranted with the pilot and with the final exploitation architecture. Can you go to the next slide, Andreas?
Yeah, sure.
Okay, this slide try to show that we are trying to be as open as standard as possible. Okay, for the Smart Fleet component, we are based the core on the fireware standard components, fireware standard architecture, and the NGSI LD protocol to access and to retrieve information, and also rely on the ETSI, and also provides us with standard or I'll say shared data models to represent vehicles, to represent the weather, and all the data sets we are managing within the pilot. We haven't pictured this in the previous slide, but we also have a data protection component, the data anonymizer, developed with by our partner Gradient, that let's say manage all the data coming, all the data ingested in the platform in order to anonymize whatever needs to be anonymized in order to preserve data protection. Okay, and finally, the AI framework that develops all the AI models, cater all the developed services, and trains the different models created within the pilot is also based on the TensorFlow and e-learn architecture, which is also well known in these development areas. Okay, that will be our standard on homogenized and open the technologies we are using within the pilot in order to implement the different components of our architecture. That will be all from my side.
Yes, and this is the end of our presentation. Now it's time for our short questionnaire. Thank you, Ignacio. So everyone, please grab your phone. You can
yes,
type
thanks.
questionnaire, the code is 162270, and you can also find the direct link in the chat. Dimitri, will you?
Okay,
put the link there?
At this moment, we have more than 32 received answers. So I would like to remind you that all answers are anonymous. So it's, let's say, it's anonymous and it's accept only one option. So it's take a few seconds. So we invite you again to participate in our questionnaire. I will share the link again. They are only 4 questions. And after that, we will have the result. So that result will be analyzed on our last part, on our round table part. So please participate in this questionnaire. Okay, let's see the results. So now we have, yeah.
Should wait a couple of minutes.
Yeah, I give you a few seconds more and I will switch to the second question because in this session we have 4 questions. So, okay. Okay, yeah, now we have a little
Dimitri,
bit more
I think
answers.
I'm not sure I see that the link you share is the first questionnaire.
Yeah, it's the first question because I give you a few seconds more to be able to, to answer. It's the first question, but yeah, I will switch to the second one, yeah. Okay, now you have the second question of the first questionnaire. Please answer.
Now we see.
Yeah.
Thank you.
It's take a little bit of time. Okay, 21 participants. Okay, I will switch.
Yeah, actually, it's, maybe it's not all interested in the motor insurance business, so we can't wait to have 60 answers in the first questionnaire, but we can give you a couple of minutes and go on with the next.
Yeah, let's see. Now we have 25 answers, so I will wait until 30 as in the first question. And okay. Okay, so I will switch to the third question. Okay, now you can see that it's the second question, but because the first one, it was the intro, so. Okay, we have 16 answers. $21. Okay. Okay. So now the last one for this first session. Okay. Now you can see it. Okay, perfect. This one goes very quickly. So that's all for my part. Then we will have more questions for the next session. So please continue with your presentation.
Thank you, Dimitri. Let's move on to pilot 12 of INFINITECH project. Real-world data for novel health insurance. Some of you may know that Dynamis is not a health insurance company, but as you know, or you will see, there are many similarities. The problem in health insurance industry is accurate risk assessment. No surprise, right? What are the pricing factors a health insurance company use? First of all, the insured person, age, gender, occupation, habits, if he or she is a smoker or not, and the alcohol consumption. Then we have the health record, if he or she has suffered from serious illnesses and diseases, or maybe a surgery. And even the health record of the family is important because some of the diseases may be inherited. And finally, the insurance plan chosen. Covers, amounts, deductibles, exclusions, etc. The problem is that premiums don't change after the first enrollment. Well, actually, they do change through time, but in a predefined manner, because of the aging or the tables of mortality. What's the solution to this problem? It's integration of real-world data in risk assessment. So far, real-world data are collected with various means, but not for the health insurance industry. We have different kinds of activity trackers, smartwatches, wristbands, clips, and many brands and models in the market. Each tracker, of course, has different capabilities, some just measuring distance or steps, some with heart rate monitoring, with or without GPS. And on the other hand, we have over 300,000 health apps available in our mobile phones, connected to an activity tracker or not. Some of them simply record activity, others offer health advice, exercise programs, and nutrition advice for a balanced diet. It seems that people are already providing their personal data like age, weight, and activity, and they provide them in a mobile app when they have something to gain from it. What if we could use the collected data in the insurance industry? Health is the app we use in INFINITECH to collect real-world data from the insureds. How we collect the data? From the inbuilt apps in Android and iOS devices. From activity trackers. So far, Fitbit and Garmin trackers are compatible, but more brands of activity trackers will be added till the end of the project. And finally, we have the reported data from questionnaires inside the application. What are the measured data? Steps and distance, floor elevation, calorie consumption, sleep time, and heart rate monitoring. And what data we ask our insured to report? Apart from the demographic data that are requested at the first registration, we ask for symptoms like body temperature, blood pressure, cough, headache, pain. We also ask for liquid intake and meals, body weight, and their mood. Actually, for the mood, we have included a weekly quality of life quiz with 5 dimensions mobility, self-care, usual activities, pain and depression, with 5 levels of responses. It's called the Q5D5L quiz. And what we do with all this data? Using artificial intelligence methods, again, and machine learning algorithms for the analysis of the insured person's behavior and lifestyle, we create a personal score. This way, insurance companies will provide personalized insurance products based on real-world data. And the result of this score will be reflected in health insurance premiums in frequent intervals. As we see in the graph, for an insurance premium period where the premiums were supposed to remain unchanged, premiums get adapted to the reports of the score in every interval. I will ask now Aristódimos from Innovation Spirit, our pilot's leader and technology provider, to give you some insight of the various scenarios and use cases. Aristódimos?
Hello, everyone. So we collect our data using the Healthensia application, and this data can be reported, as we said, and you can see that on the left-hand side picture here, or we measure data using, again, the application, and the data collected are shown on the right-hand side. All these data are processed to gain some insights. We understand the long and short-term averages and trends of data, things that are shown on the bottom graph here. And then the time comes for learning. Our classifiers try to understand what conditions will lead to improving or to worsening the outlook of a person's health. And the machine learning algorithm, based on the data, decides how to weight its decision based on the behavior, the demographic information, and factors from the person's medical record. Then we actually collect decisions across time in order to reach our risk assessment. And the risk assessment can be seen as it progresses through time for two different cases in these two bottom graphs here. A risk assessment that is quite positive and a risk assessment that is somewhat negative. This risk assessment is the score that will be used in order to give an advice to the insurance company on what they should be doing with the premiums of this particular client for this particular period of time. Thank you.
Thank you, Aristódimos. Of course, we have a new challenge to deal with, and this is fraud. It has been noticed that people who use activity trackers and mobile health applications try to fool the devices just to advance a level in a loyalty plan or to earn a badge, with no monetary benefit from their action at all. Imagine what will happen if lower insurance premiums are at stake. We have two approaches to deal with it. First, during the project period, we train the algorithms with real data, not dappered in any way, from volunteers with no personal benefit. So this way, we will detect such misuse of an activity tracker in the future, when the pilot will have been integrated in the insurance business, of course. And the other approach is to tend the insured person to give the real data of his behavior and lifestyle by providing accurate assessment of the risk on various health domains. Let's summarize the business innovation in health insurance that our pilot brings. One, as we said, is usage-based insurance in health insurance sector. From the view of the insurance companies, they will provide to the insured personalized offers based on the actual risk, by capturing and processing real-world data from them. From the other point of view, the point of view of the insured, their premiums will be adapted in their behavior and lifestyle by providing real-world data. So this may be a motivation to a healthier way of life, resulting, of course, to better results for the insurance companies as well. The other innovation is fraud detection, as we said. We will train properly the algorithms in order to detect abnormal behaviors by using trusted data from volunteers. And we will provide the insurers with accurate risk assessment on various health domains, so they will be tempted to get real data instead of fake ones. We hope that this will make them think that it will be a win-win situation for insurance companies and clients. Aristódimos, back to you to present us the pilot architecture and the technologies used to implement the services.
So our pilot is about what we are building in order to make this system happen. It's not what the insurance companies will be using when everything is ready. I will explain the latter part in a while. So we start with the Healthensia platform, collecting data, either data that are measured and reported by real people, or data that are provided by our real-world data simulator. We need both because we need a wealth of data in order to start training our algorithms, and we hope that we will be changing the mix of simulated and real data pretty soon as we proceed with our pilot and we get more and more actual data into the system. The INFINITECH data collection system collects all this data and cleans it up and then provides the data to the regulatory tools that perform anonymization, and then the data are stored. The AI platform gets the stored curated data and derives profiles, both lifestyle profiles and also classifiers, lifestyle classifiers. These allow us to build the risk assessment and the fraud detection services. These services in the pilot work online with the data that we collect from the database, and the results are reported back into our portal application for viewing by the insurance companies. At the end of the pilot, when our classifiers for the risk assessment and the fraud detection will be ready, then we can offer these services to the health insurance companies, and they can get them as standalone services, and they can connect them to their own data streams that can originate from Healthensia or their own data capturing system. And they will also be able to connect the outputs again to their own visualization system, or if they wish to do so, back to the Healthensia portal application for visualization by the insurance professionals. Going now to the technologies, similar to Pilot 11, we are trying to be as standardized as possible, but for data collection, we use a proprietary system, the Healthensia system. Data protection, though, is built again on the very same system Pilot 11 uses around the gradient data anonymizer. Understanding of the data and service provision is done using well-established frameworks, the TensorFlow and the scikit-learn. So thank you.
Thank you, Aristódimos. This is the end of this pilot presentation. As before, you can find the slide on your browser or the link in the chat to answer our short questionnaire. Dimitri?
I will share the link right now for the questionnaire 2. So as the previous one, so you can use the direct link or use the mobile application with Discord, so as you prefer. The pool is open, so you can answer to the questions. There are 5 questions in this session.
I don't see any poll.
Just click to the link which I just shared with you. questionnaire 2.
Okay, yeah, sorry.
Okay, we have more than 25 answers, so let's go to the second one. This one is multi-option, so you can choose 3 options. Okay, perfect. Let's go with the third. Okay, let's go with the fourth. We have 27 participants here. Excellent. Let's go with the last one for this second session.
Perfect. Thank you very much, all of you. Yes, I think Dimitris is going to close.
Yeah.
Let's